welcome to the new session. Today we are going to talk about survival guide to typing in Python. We have, our speaker is HanaPoulpe. Well, Hana is a former dev at Amazon. She has a related to Python, AWS, database, DevOps, and many other things. She's a backend dev at Kraken Tech. She's working mainly with Python, like something of testing and making code predictable. Welcome, Hannah.
Hello, thanks for having me, Monica. Welcome to everybody. So, as Monica said, I will be presenting a talk about how to work with static typing in Python. So basically, I think many of you have already used MyPy, and for what I hear, sometimes it's a pain to work with MyPy because typings are not that easy, and there are a lot of traps that you can fall in. So I will just get through some of what is static typing, how it can help you. Should you use this? Some concepts that are very, very useful to understand with typing, some best practice, a bit of toolbox, and also a bit of dynamic typing, a look on it, because, well, first point is what is not static typing? So static typing, well, that's easy. You have already saw this many times, I think. That's the typings you can add to your function, to any part of your code, to help you understand what object you are working with. But static typing, it's not magic. It's not something that will do autocast. That's not a magic tool to cast from a type to another in Python. So what I mean by this is, well, if you have worked in more static languages like Java or C, when you are going from one type to another, let's say from a int to a float, you will automatically cast. You will change the type, change the representation of the data in memory to match a new type. Sometimes you have to type manually. In Python, you always have to do this cast manually. So static typing, it's not something that works at runtime. That's something that is static when your code is not running. That's also, that means that what you declare as a static type, what your typings declare, can differ from what you really have at your runtime. So you need to be aware of this, and you need to understand how that will help you and what are the traps. And also, static does not promise any immutability in your types. What I mean by this is, in some languages, like Rust, for example, most of the time, by default, your parameters, the parameters of your variables are immutable. You cannot change them. But static typing does not grant anything about this. So that's really important to know this thing, because that means that no matter how you type or you declare your function, these three elements will never be covered unless you do it manually. So it's more of an interface contract. That means that you say that your method, your class, your function is expecting a certain type of parameters, certain type of input, and that it will give back a certain type of output. And that will help you understand what object you will give at any given point in your code. So basically, that means that if your typings are right, you can know what are the methods, what are the property that any of your objects have at any given time. And that's where it will help you. But should you use static typing? Because that adds weight to your code. That's something you need to think about. And I think that's really important to understand that when you start working a lot with static typing, and even more if you are not used to this, you will start to think more ahead about your code. You will think of your implementation before writing it. And that's something that will help you being better developers. It's also a cheap way to document your code, because when you have a function and if you don't type, if you don't put doc strings everywhere, if you don't write thorough documentation, having your typing right will already give you a big understanding on what is going on and what are the objects you should give to your function. And that will help you avoid issues like attribute errors. That's something that happens when you try to access to an attribute of an object in Python that does not exist. And this error can be a pain to debug and to figure out, because that's something you cannot see just by looking at your code. You will need to go in the real-time execution of your code and see what happened, what are the expectations that were not granted, that were false about your code. It will also help you to see if you change anything about your function and its signature. So signature is the name we use usually to speak about what are the parameters and the return type of a function. Because if you are running your MyPy, so your static typing tool, after at testing, you will get issue if the type are not matching, and that's something that is really helpful, because before trying to figure out why your test is not working, you know already before running any test that it might not work if your types are not correct. And well, to answer the question as should you use static typing, personally, I use it in any of my projects, being the big one that I work on professionally or the small project that I have for myself, because it's something that becomes a reflex really fast. And once you have this reflex, that means that you can do your work on some part of your code, forget about it for a few months, get back to it, and at least understand what was your function taking as parameter, and that's something that really helps to get back at what is your code doing. So that's something really important to have. So for static typing, you have to understand a few. Really, to get really great at typing, you need to understand a few concepts about typing. The first, and that's not the one you will use the most, but I will get to later about why you want to use generics and when you want to understand how generics work. Generics are a way to write a function that will do the same operation to different types of object. So here you see on the screen two ways of writing it. The first one is for older version of Python, so Python 3.11 and before, and the right one is for Python 3.12 that change a bit of the syntax on generic to make it easier to read. So that's something that is useful. And yeah, so basically a generic type, as you see on this example, I create a class that is performing an addition, that applies an addition between two numbers. Basically, something really simple that for understanding it. And well, if you give it an integer or a float, it will work. It will do the same operation. You don't have to write one class to do an addition on float and one to do an addition on integers, because both type has the operator that is the plus operator. So that's easy. And the example is really simple for you to get an understanding on what is going on, but you can have more complex types into it. And yeah, basically that means that if you are using an addition, you can use it with integers, you can use it with floats, and you know also that the return type of your apply method for your addition will be the same type as the one you passed in. That was generic is saying in this example. And well, that means that you can write a function that will take two objects with a common setters, for example, or a common method, and that it will return the same type at the return. And that's something that we will see a bit later. Really important for how to work with iterators, with generic types that exist in Python. Aside from this, we also have another thing in Python. For people who have already worked with TypeScript, you already know it, that's the structural typing. This one is very useful to, let's say you want to apply to have a method that is, in this case, just extending the example before, the operation class, that's a protocol. So that's how you define static typing in Python. Well, you can pass to your apply to all function the same any operator, and an operator will be any class that have this apply method that takes two numbers and that returns a number. So that's something that helps you to avoid creating very complex and convoluted inheritance strategy for your classes. You can just create a protocol at the start of your module and use it to say, I will do dependency inversion here, but I know that I will have an object that must have this method. And that's a good way to do this and to avoid having to import a common layer at the start, a common object that will be an ancestor of all the objects you will use. And also, something that was really complex before Python 3.11, and again, Python is moving a lot with the types, so that's why sometimes you see for the new version, I just specify the type. For Python 3.11, you have the type that is self with a capital S. And basically what this type means, that something you can use inside of a class, and that means that it's the type of the class you are currently declaring. And or the subtype if you are in a subclass. So for example, for this example, really simple, create a vehicle that has a create instance method that returns self. And well, this create method, we can then use it in another function that will use this create instance and that will take any subtype of vehicle as a parameter. And we know from the typing that it will always be the type that an instance of the type we passed. And really important, because that means that the code you can see in the main here will work and will not raise any exception in MyPy, because you have declared that what you get from create vehicle is something that is an instance of the type you passed. So we expect our car to have an engine, but we expect our bicycle to not have an engine because it's not existing in this class. And using the self type will help you with this. So a bit of best practice, and that's the most important part of this talk. That's the best practice that you want to apply. And well, best practice that will be first, your parameters should be the widest as you can. And that's where you will using a lot of time. You declare something, you say, yeah, that's taking a list, for example, and that's something I saw a lot. You declare something as taking a list as an entry. But if you are just doing a for loop on this list, that means that it can be just an iterable. And by declaring that you want an iterable, that means that you can then provide a range to your same to the same function. You can provide a generator, you can provide a set, you can provide any kind of collection that you can iterate on. And that means that you will avoid having type issue that you will solve by casting a set to a list, or casting, if you are working with ORMs, casting query sets to list. You don't have to do this if you are already saying that it's something you can iterate on. And that's something that is really important to know. And at the opposite, you want to provide as much detail as you can on the return type. And this also is super important, because the more details you will provide as a return type, the easier it will be to work with other functions in your code. Because the more detailed type, the more attribute you are saying you are providing to your object. And that's really the best practice that you need to apply when you are typing. Take as wide as you can as an entry and as narrow as you can as an output of your functions. Also, bit of toolbox, as I was saying. So MyPy will basically look at your code, look at the type-ins, and find where you have any issues. You have there is a GitHub repository associated to this talk, and you can download it. If you are creating a project that use a pyproject.toml, you can use a very small tool.mypy part of your configuration that will configure MyPy to alert you if you have anything that is not typed, that will help you type everything all the time. That will help you to see if you have redundant casts, if you have stubs that are not complete, and if you are missing any part. You can also set MyPy to tell you if you are doing an assert that is never to be true. That's something we will see just a bit later with what are the dynamic typing that you can use in Python. And also, if you are creating a big project, you can also use MyPy. MyPy comes with a stubgen command that helps you create stubbers. So stubbers are Python files that have no implementation, but that contain all the typing. And that makes easier faster for your IDE and for MyPy to understand all the typing. So that will make your type checking faster to create stubber. And a lot of projects will come with a stubber also. And also built-in module. So I will go really fast. You have the typing module, really important with meta types. and collection.abc that stores all the collection modules, all the collection type that you might want to use at some point. And just a last quick part on the static to dynamic. So Python has two ways for you to work with static typing. The first are TypeGuards. TypeGuards are functions that helps to know, basically, if you are running a TypeGuard, that means that whatever you pass as an entry of your TypeGuard, if you assert that your TypeGuard is true, the return type of your TypeGuard, the parameters of the type, will be the type of your class. That's something that will help you casting using just an insert.
Thank you, Hannah. Well,
yeah, that was dense. I know. I don't know if we have some time for a bit of some question from the chat or not.
Unfortunately, we don't have the time, but we have these useful links that you are sharing with us. Really nice to hear about your talk. And Hannah, I don't know if you have something else to say just to finish the session.
Nothing. So thanks a lot for inviting me. And yeah, maybe if you have any question, feel free to ask them in the GitHub repository. That should be linked to the talk. So I can answer them, there. So thanks a lot.
Thank you. Thank you so much, Hannah.